Good morning. My name is Gaurav Singh Rathore. My roll number is 20951A1223. I am from Information Technology branch. Today in this conceptual video, we are going to discuss the topic binary search. So let us see. So introduction. A binary search can be implemented on only sorted list of elements. So this is the main point. The process starts with finding the elements at the middle of the list and comparing the key value with the element in the middle of the list. If the value of the key is less than the element at the middle, then the search process the key to the list up to the middle element, and if the value of the key is greater than the element at the middle, then search the key from the middle of the element and the list. So binary search, also known as half interval search or logarithmic search, is a searching algorithm that finds the position of a target value within a sorted array. So binary search runs in at first algorithmic time makes O log n comparison, where n is the number of element in the array and log is the binary algorithm, and using only constant O1 space. So let us see the algorithm. So here is the binary search. Suppose there is an array starting from 0 1 2 3. This is index till n minus 1 and comma key which we want to find. So we will give low one one value, low is equal to 0 and high should be n minus 1. So this is, so low is the first index and high is the n minus 1 index. So while low should be less than high, then we will start a loop where m we will define mid element as low plus high by 2. So if the key element is equal to a of middle index, then return m. Otherwise, uh, key should be less than am. Then high will become m minus 1 and low will be same. And if this does not satisfy, else low is greater than m plus 1. So we will see this now. Let the number given be 4, 6, 7, 9, 10, and the key is 9. So according to the algorithm, these numbers are to be sorted in 1D array name as A 0, 1, 2, 3 and minus 1, where n is equal to number of elements. That is an example 5. 1, 2, 3, 4 and 5. So thus according to the algorithm, A is equal to 0, 1, 2, 3, 4 is the generated and key value is passed in array, then binary search 9. Low is equal to 0, high will be 4, while low is less than high, the condition is satisfied. Now we do the first iteration. M will become low plus high by 2, that means 4 plus 0 by 2, that is 2. Now low is equal to 3. Here key is equal to 9, which is greater than a of m is equal to 7. Thus it executes last else condition. Since 3 is less than 4, loop will continue. Iteration 2. Now m is 3, returns 3. Since key is equal to 9 is equal to a of m is equal to 9, where m is equal to 3, thereby value is returns 3 and thus ends in its binary search, returning the index where the value is stored. See, in this we want to search 23. Low, initially low is 0 and number of elements n minus 1, this is 9, total 10. So mid element is 16, m is equal to 4. Since 16 is greater less than 23, now we will search in the second half from m4 to 9. Now low will become and mid plus 1, that is 5, and high will become 9. So now we will check the middle element, that is m is equal to 756, which is greater than search element. So now we will check in the left side. Now high will reduce, that means m minus 1, that is 6, and low is same. Now we will get the we found the element at index 5. So now it will return the fifth index. So here is the code this in Python. So this is a recursive method. So it will return the index of x in an array if present, else it will return -1. So we'll give a method binary search arr l r x, where arr is the array, l is the lower index, r is the right hand side, and x which the element which we need to find. Now check basic case. If r is greater than 1, mid is equal to l plus r minus l by 2. If arr of mid is equal to x, return mid, else arr of mid is greater than x, return binary search arr of l comma mid minus 1 comma x, else return binary search arr mid plus 1 r comma x, else return 1. So the driver code is 2 3 4 10 4, and we need to find x 10. Now result is equal to binary search of arr 0 length of arr minus 1 comma x. If result is equal to -1, print element is present at index percentile results, else print element is not present. So output is, since it is at the index 3, so it will, the output will be element is present at the index 3. So the time complexity is O log n, and space complexity big O log n. Now we'll see the time analysis. Suppose we have an array A, and in this array we are searching for a value k. If A has no special properties, then there is no better way to search k in the linear search. To start at the beginning and go through the array one step at a time, comparing each element to k in return, the time is taken on average, and in the worst case is linear, or O(n), big O(n) to the number of items of the array. But if A is stored is a sorted array, there is a much faster way, binary search, to look for k. In binary search, after each iteration, the length of the array we are looking is gets cut in half. So so the binary search can be analyzed with the best, worst, and average case number of comparison. These analyses are dependent upon the length of the array. So let the n is equal to modulus a, denoted the length of an array A. So the number of comparisons for the recursive and iterative version of binary search are the same. If comparison counts is relaxed slightly for recursion, binary search count each pass through the if then else block as one comparison. For iterative binary search, count each pass through a while block as a one comparison. So this is time analysis. So for best case, big O(1) comparison. In the best case, the item X is the middle in the array A, a constant number of comparison, actually just one. So if it's in the middle, we found the element, it will, the best case big O(1), and the worst case is big O log n comparison. In the worst case, the item X does not exist in the array A at all. Through each recursion or iteration of binary search, the size of the admissible range is half. This half can be done ceiling log n times, thus ceiling log n comparison are required. So we need to keep in mind that the array is in a sorted, then only we can search. The average case O log n comparison. To find the average case, take the sum of all elements of product of number of comparison required to find each element and the probability of searching of the element To simplify the analysis, assume that no item which is not in the A will be searched for, and that the probability of searching for elements are uniform. Advantages and disadvantages. Advantages are binary search is an optimal searching algorithm using which we can search desired elements very efficiently, and the disadvantage is this algorithm requires a list to be sorted, then only this method is applicable. Now the applications are: the binary search is an effective searching method and is used to search desired record for database for solving non-linear equations with one unknown. This method is used. So with this we would conclude the topic. Thank you.